Good afternoon, ladies and gentlemen. I'm Chak Weisel, an associate professor of the Division of Chemistry and Biological Chemistry. Today, it's my great honor to introduce my speaker, Professor Herbert Roesky, to give a talk. Professor Herbert Roesky obtained his PhD degree in the University of Göttingen. After working at DuPont in US, he returned to Göttingen and finished his habilitation. Then he became a full professor at the University Frankfurt am Main in 1971. After that, he moved to University of Göttingen and was the director of the Institute of Inorganic Chemistry until year 2004. He's highly famous for his pioneering work on the fluorine chemistry, especially for those transition metal and main group elements. Then after that, he shifted another research area to aluminum chemistry and then to silicon chemistry. He has more than 1,300 publications and numerous awards. If I want to voice out all his awards, I think I need to spend 1 day or 2 days to finish, to announce all his awards. So I choose some of the most important awards. The first one is 2004 ACS Award in Inorganic Chemistry. Year 2004 Witting-Grignard Award in France. Year 2015 Blaise Pascal Medal, European Academy of Science, Belgium. So now is my personal feeling to my Professor Roesky. He was my supervisor in year 2006 in University of Göttingen. Professor Roesky is my idol, okay? He's my idol in my whole life. He teach me chemistry. He teach me how to have a critical think, how to think other people cannot think. So we are talking about a lot of things with different kind of views. He teach me how to be strong in the laboratory, how to be a strong man, how to think good ideas, how to work hard. He's my role model. He brings the happiness of chemistry to me. And then now I become the professor of NTU. I also want to bring the happiness of chemistry to the young generation, to my students, to the audience. So today the title of the lecture is Art Gallery of Chemistry. Welcome, Professor Roesky.
So thank you very much for your invitation, and you praise me. Don't believe what he has said to you. I'm just a normal being, you see. I have 2 legs, and I have a head and 2 arms, so I'm not an exception. I like you see, very normal. So I want to tell you, let's say, kind of a story, which is you can, first I would say, lean back and relax, completely relax, so that you can enjoy chemistry from the beauty side, okay? Let me first, let's say, show you a few pictures where I'm coming from, and where I was born, and why I became a chemist. That is, well, I explain you shortly before I tell you, let's say, something about chemistry. I was born here in this village called Laukischen. That is, this is the Baltic Sea. Here we have Lithuania, here it's Poland. But after World War II, it was divided. This part is now belongs to Poland, and this to Russia. So you can say, let's say, I'm a Russian, not a German. I'm Russian because I'm born in that place. That is the first one, and maybe a little exceptional. Okay? So this is in this window here, I was born. Then my parents had a dairy. And my father and my mother, let's say, they run a dairy. And I have an older brother and an older sister I had. So I had also a grandmother. And show you this today. Looks now to how it looks today. This is me, and this is my grandmother. So I was a small boy, but my grandmother raised me because my parents had no time. They were busy, let's say, making cheese and butter and so on in a dairy, okay? So this is me, and that is my brother. And the war came, and it was 1944, and we had to escape because Russian troops came to this part of Germany. So we had to escape, and we were separated from my parents for about 1 year. So my brother and myself, so we traveled around and escaped, let's say, from the soldiers. This is my mother, my father, my sister, my brother, and me. So that was our family. I'm only the survivor of the family. The others are already passed away. This was my wife, and I married her, let's say, then after my PhD in Göttingen. So before I come to this, I want to tell you, let's say, my grandmother had a very strong influence on my life. And she said, well, you are the right child to take over the dairy. And after the war, let's say, I learned to make butter, cheese, and everything what is to learn. And I can tell you, let's say, a story about how to make very good cheese. But I think that is not very interesting for you. So with this knowledge, that was my first profession. After I had to learn for this 2.5 years. And then I was thinking, that is a boring job. We could not go back to East Prussia and there and say to work in a dairy a lifetime. I had to get up at 2 o'clock in the morning. And I was lazy. That was also not very nice. And then I decided to go to Göttingen and study agriculture, because with the background of a profession in dairy, you could have the allowance to do agriculture. So I went to inscribe, and then the man in front of me said, did your father have a farm? You want to study agriculture? Said, no, we have no farm. We had a dairy in East Prussia. Or he said, you never will return to East Prussia. It belongs now to Russia. I know, I said, but the influence of my family was very strong, so that I was optimistic one day going back and doing there the job. Or he said, your chance is not very high. Then I asked him, what do you recommend what I should study, let's say, if not agriculture? Oh, he said, I have heard that the industry, German industry, needs chemists. Oh, I said, chemist? I have done, let's say, something in the dairy. You see, I had to determine content of the grease in the butter, or the water in the butter, and so on and so on. You have to make analytic experiments there. And so I said, inscribe me. So that was within, let's say, 10 or 20 seconds, I decided from agriculture to become chemist. So that was how my career started in chemistry. So I show you, let's say, the periodic systems. You have, let's say, I think a smartphone, right? Most of you have a smartphone. The smartphone has presently 31 elements. 31. Can you imagine this? All these, where you see this sign here. All these elements, silver, indium, tin, I will not go through this. You see that takes an hour. Lithium, magnesium, and so on and so on. Dysprosium, gadolinium, rare earths, all are in the smartphone. But the chemists are not educated afterwards to separate these elements. So therefore, let's say, the chemists are responsible to do, let's say, the work up afterwards when you throw it away and buy a new one. So I can guarantee in 5 years, maybe 10 years, no one will have ever a smartphone. It's too expensive. And the work up is too complicated. You can work up, making, let's say, recover platinum, gold to elements, and so on. Therefore, I'm showing you this, that we have to do, let's say, some chemistry, let's say, which are plenty available. Silicon. Here's the silicon conference now. Therefore, let's say, this is the progress that you replace these precision metals, rhodium, ruthenium, osmium, platinum, as an important catalyst for the production of making your polymers, which you are wearing, the colors which you are using. These are normally not natural colors, but synthetic colors. So, to explain to you why I studied chemistry. Now, the most interesting and important question is, how can we attract young, intelligent students or girls and boys to study chemistry? This is very, very important. Or, let's say, chemistry and engineering, because it's very important for the future. The chemists are making the materials. When you step here, let's say, on this is done by chemists. When you look, let's say, here to this black color, this is done by chemists. The walls here, let's say, or the white one, or the projector, and so on. The materials are prepared by chemists. If you have not in the future, no chemistry anymore, and engineering is also very, very important, then there's no development on the earth. That you have to realize. Even, let's say, if the public is against the chemist, that they make some things which are not so good for the world. This we have finally to avoid. First, I started, let's say, to convince the young generation by books. I wrote several books, and all the books are, I have a foreword. Maybe you know this. This is Nobel laureate. So he supported me in all this, in these efforts. So when you have, let's say, on the cover, the support and inside you can read it, let's say, the foreword of a Nobel laureate, then the younger ones and the older ones believe that this must be good. That is also important. So Manfred Eigen, he was also passed already away. Raoul Hoffmann is still living in the United States. He passed away about months ago. And I introduced micro experiments. Do the reaction in one drop. And use, let's say, I will show you this food colors for doing, let's say, kind of reactions. I come back to this later. This is George Olah, also a Nobel Prize winner. Wrote about spectacular chemical experiments. Sometimes you must do, let's say, oscillating reactions. You must make a bomb and so on. This is also, if you do it in a controlled way, it is stimulating. And also, let's say, experiments in green and sustainable chemistry. That's Jean-Marie Lane, is also in Strasbourg, in France, also a Nobel Prize winner. So all these books were supported, and the idea which is behind the books by Nobel laureates. So therefore, I think my direction was going, let's say, in the right way. We have a period, let's say, of alchemy. It was a very long time, 300 before Christ and 60, 50 after Christ, and almost 2,000 years. And Antoine Lavoisier, a French chemist, he showed for the first time, let's say, to do quantitative reactions, controlled reactions. So we still have alchemists. You see, if someone comes and says, oh, look here, I have a powder, and if you eat this powder, you see, you give me 1 million for this, and then I can guarantee you are becoming 110 years old. Yeah? If he believes it, he will accept my offer. You see, that is alchemy. So they have not a good background, but you still have these people around. And the alchemist did experiments in the public. So this is one who discovered phosphorus. And how did he discover this? He used his pea, see? And he condensed it, and then he has a phosphate. The phosphate was reduced, and then a small amount of white phosphorus is forming, and the phosphorus escapes with the water. It goes in there. You can do this experiment very easy and oxidize, and this is called the phosphorescence for the first time. So this experiment was important. So he was hired by a king, and the king was thinking that with this technique, he can make money, he can make gold. Huh? That was the driving force. You see, the people normally, let's say, shoveled gold. They're still doing this. See, when you are looking, the rich one, they have heaps of gold. Some, let's say, in China, they cover the ceiling with gold plates. Or I have seen this, the walls. they believe in gold. You see, gold makes you happy and so on. So this goes back to that time. Here, this is grapes, and here you have an alchemist, and he gives advice how he has to do it, let's say, to do the reaction. And this is very characteristic, a picture. You probably have heard the name Liebig. Liebig, maybe that is a condenser, Liebig condenser. Do you know this? Have someone heard about it? And that was a chemist in Munich. And he learned, he was also a pharmacist, and he's advertising, let's say, some important ingredients. And Liebig wrote the following. At the marketplace in Darmstadt. Darmstadt is a town close to Frankfurt. I picked up from a street trader how they transformed detonating silver to his toy torpedoes. That is, to explain this, is when you have silver and you add ammonia or any nitrogen to this, it makes an explosive nature. So when you heat it, and make bang, and this is sold, of course. When he dissolved silver, the red vapor showed, let's say, that was the oxidation, nitric acid in a liquid which is cleans the dirty jackets which smelled like alcohol. That is what they in these times use, let's say, as chemicals to convince the people who to pay them. You see, to pay them money and use their ingredients. Here you can see his glasses are already, let's say, have the tendency to gold, yeah? Yeah. He studied in this book and looked to this glass. It looks like, say, like gold. And he wants to sell gold. But what did he sell? That was a mineral. That's pyrite. Pyrite, you find, let's say, all over the country. That is a mineral, and that is very cheap. You see, it's iron sulfide. Iron, not gold, iron sulfide. This they sold it, that they say, well, we can convert, let's say, minerals to gold. And people believe this, you see. They had no other chance. They were convinced, they looked to it, and then there he obtained money for it. This here is solution, and he changed the solution, and I will make an experiment for this that you can see. Normally, let's say I do 10, 20 experiments. Now only one. This is Carmen Insign. That is wine. Who wants to taste it?
Goodbye. Good wine.
Yeah, then you can have everything.
Thank you.
Therefore, I have 2 glasses, you see. So this is a natural color, you see, red. So wine is especially for older people, for your father, you say, or your mother. They very often, let's say, at home or when they travel, they enjoy, let's say, red wine. So then you come to the border. Say, especially, let's say, in former times. We change the color. Now it looks not red anymore. Can compare. This looks black, right? Yeah. And this red. Yeah. So when you come to the border and the custom comes and he looks to this, what is this? You can tell him, that's old oil. Yeah. Used oil, you see? Of no value. Okay, said, pass. Then on the other side, then you are coming, let's say, then to Singapore. Then you recover the wine. You refuse to taste it. You are a good chemist. Yeah? You want to taste that? No? But then you can pass. You can go over the border. And you have not to pay the toll for the wine. Of course, that is a joke, you see. You will not do it, but that is how you can, let's say, play alchemist and tell the people something. So normally, let's say the experiments I'm doing is with so who has nothing? You want? Yeah, okay. More? So the first row I have to give them to be polite. This we call gummy bears in Germany. You know this? Yeah. So if you do not eat it, take it home. I saw already you sleeping. You have to have a gummy bear so that you become awake. Everyone? More? Who wants more? You have also? Oh, you know, okay. Now, you are so busy. Please. And you? Also photo. And this for your colleague. And this empty. Okay, so normally I'm doing, let's say, all to my lectures, I'm doing this with doing real experiments. But I will show you, let's say, also some different. This I will skip. Then I was in London, and I was going, let's say, to the National Museum. And here you see a typical chemist is doing, let's say, in the presence of the audience, an experiment. But what could I learn, let's say, from this picture? Look to this young man here. He is not watching here. He's looking to the girls here, you see? And this here, you see this older man here, he looks to this ladies here. See? He is sleeping, okay? He already slept. That is how the audience, when you are a teacher, how the audience behaves, you see? They are not watching the experiments here. You see, also this guy here, he looks also to this very nice ladies here, an older one, and they talk, you see. They have to exchange their news or something like that. So then I was thinking, writing books, nothing helps. How can we interest the young generation to become chemists and engineers? I was thinking, let's say, taking the peanuts. You know the peanuts? Of course, I'm sure you know. And that is, they have a theory. I'm going to color the sky blue and the grass green. Okay? The ideal location to observe a grass green would be in a temperature zone at a place not lower than 36 degrees latitude at a distance of from 1 to 10 yards during midday and. Now the answer, don't forget that grass green is an elusive term. The color of grass green can be changed by the turning of the blades as they are blown by the wind. So that is an explanation. Yeah? But look the reaction. Yeah? That happens, let's say, when you have a teacher and he explains you something, let's say, confusing, then you naturally you have the right reaction for this behavior. So the best idea cannot be realized when we have no students to do the experimental work in the laboratory. How can we attract young people and how they are becoming fans of chemistry? That is very important. So what is the most important sport, what you are doing here in Singapore? Cricket? Baseball? Football? What? Football. Yeah, it's important. So you are watching TV or you are kicking, yeah? Right? So, or you're watching, let's say, Manchester City or Liverpool or something like that in the TV, you see. Therefore, but they have fans. 100,000 are coming, let's say, for play. Free, they have to pay. You see, to watch a play, they have to pay. Can you believe this? That is possible? There are really, fans are doing this only. So when you have to pay, let's say, $100 or something like that for a game, and you have 100,000, see, that is free, and you doing this. So then it was the idea which I had, how can we make fans for chemistry and engineering? Then it would be, our life would be ideal, right? So what are the most interesting and most influential technical things for young people? Computer, iPhone, television, right? Can chemistry compete with toys, with these toys? The answer is no. Therefore, the logic consequence should be, if you cannot beat them, join them. So that is the message which I can give you, let's say, for the younger generation. And I know, let's say, when you have now, let's say, when I stop or in the meantime, when it becomes boring, and you are, then you take your my iPhone, and you are concentrating on the iPhone and not like you see, you have it already in the hand, you want to show, then I know this reaction. when especially, let's say, the younger ones, they cannot live without this action. This gentleman, let's say, looks to a computer and writes his a letter to his girlfriend. You see him writing? Yeah? Yeah, you smile. I was not thinking that you do any reaction, but you do. How can we combine chemical experiments with computer and television? We have developed, let's say, chemistry on miniature. We'll go further. You cannot use, let's say, these type of, they call it Schlenk lengths. This is also, let's say, test tubes. The reason why you cannot use this, when you are doing an experiment, let's say you dissolve, let's say, one of these gummy bears, you want to do a reaction, that's easy to do. You cannot go with a test tube in your pocket. You see, when you put it in a pocket, then you walk, and then it becomes wet, and then the red color, let's say, goes down. Eh? That is not nice, you see, when you have, let's say, a nice shirt or trousers or something like that. So, therefore, you have to make pictures. This is very important. Now I tell you, let's say here, you can make concentric rings in solution. That's very easy. When you do a titration through the gas phase. Can you see? You have a Petri gas, and then you normally, let's say, when you make a let's say a neutral, you add, let's say, sodium hydroxide, or when it is basic, and you add, let's say, HCl, liquid HCl, but you make it drop by drop, right? That is the reaction. So you see nothing. Eh? This is. What you can do is you take a paper, you suck the paper, let's say, with HCl, and you put it here on these, and here you have a color, and then you make concentric rings. You can make, it's unbelievable. It works. You are doing the titration through the gas phase, not direct liquid in liquid, but the one gas and the other is a liquid. So you can make very interesting figures. Okay. So this is what you see in Paris. There was a fire, and this was destroyed. This, and I was in Paris many years ago, and I could, let's say, take this, how beautiful this is, and shows you also this kind of concentric rings. This is here also a reaction of the blue color with in the Petri, on a Petri disk, with you doing, let's say, you have some through the light, you have some thermic, and then you make a picture. You can make a photo of this, and then you can sign, let's say, Li, or Chang, and then the date, you see, and then you can bring it home, go to your father, and then and to the mother, and say, yeah, that I have done. You see, we have shown the experiment which we have done, let's say, in the school or at the university. And the mother is very proud. You see that her son or her girl is doing, let's say, something interesting. She is becoming a chemist and an artist, both at the same time. So then you get a phone call from home and said, oh, you are making, let's say, very beautiful pictures. Yeah, I said, not me. That was done by your girl, and she has signed this, as you can see, and very different pattern you can form. It is something like these are the clouds, you see, on the, you can generate like nature, you see. You see here it's dark, and here's the white ones in the back. When you watch this, for example, when a thunderstorm comes, you see, so you can compare this with, sometimes this is ice, and here you see the penguins. This is natural ice in the south of Argentina. It's Lago Argentino. And you wonder, let's say, the mountains here have no snow. How happens it that you have here ice and there you have in the back you have, and this is the reason is you have very strong winds there, 200 kilometers per hour, and then the water freezes to ice. You can make also, let's say, flowers. Flowers in a Petri disk. See, this is a flower, and here this is the indicator, this is yellow, and through the reaction here in the center, you turn, let's say, the yellow to blue. And this is also, let's say, the pictures are becoming better. Or you can make this type of pictures. So you have to cut, let's say, the piece here. You may have to make sharp edges. And then you have these leaves here coming out. So you can play with the chemicals very, very, very simple. This is reactions, let's say, with natural products. So if the kid's coming, and so sometimes they do something with the finger, and then and so here, no? And that is allowed because the chemicals are not toxic. Have you tried it? No one died here, huh? So far. That are the natural products. This is, call it the Purple Volcano, which you can make. This is a tree, fantasy tree. Here you see the water spots here from the glass here also. I did not remove this, so it is not artificial. It's really done. Can do, let's say, this kind of experiment. This is a teacup or coffee, and then you see the steam coming out of the cup. This is a picture which you can prepare if you have several of these, a mixture of these colors of the, and you bring this in solution, okay, and then you, with an injection, with a syringe, you put in, and then you see this changing the colors, and then you can sign it Y, for example, and then bring it home, and then you're becoming, let's say, very, very famous in the family. And then when the neighbors are coming, you see your parents, we put the pictures on the wall, and then they say, when the neighbors are coming, who has done this? Oh, my daughter. Oh, wonderful, let's say. How has he done this? And then can I send also my kids to that professor who's doing this? No, the professor has not done it. This has really done, let's say, my girl Mariano, or with her name, because she has signed it here in the so that is the work of the daughter, which has done. Signing is important. Oops. How happens this? I don't know. I think you can know Vasily Kandinsky. Every work of art is a child of one's time. Often it is the mother of our feelings. Every cultural people creates a special kind of art which cannot be reproduced. The effort to revive former art principles might only produce works of art which are doomed to failure. This is, of course, this is a picture which is prepared by Franz Marc, and Vasily Kaminsky called it the association of a blue horseman, I have to say. Blauer Reiter means blue horseman. They lived in Munich and were famous, let's say, for their painting. But that was done, that were really artists. They used, let's say, to paint it honestly. And this is what the children are doing, let's say, the green forest. Or here, let's say, the green one, and here you see the shadow, or here, let's say, still from the cuvette. This is the red one, and they give you, let's say, kind of explanation what it is. Say, well, you can bring it, let's say, to Robert Hooke, and the surface of the Saturn and Neptune has this kind of color, and so you can compare this with the elements. Here, this is the natural which you can find. This is the red and the black ones, and here some blue spots, the new modern. What would you say, what is this? That's the surface of the sun. Yeah? So you can compare your pictures with natural things. The blues and kind of the sky. Here you see the cuvette. It's not, let's say, something which has not been done. This doing the children are doing, let's say, this kind of reactions, and this is a real picture. That is a Renoir. You have to pay, let's say, for this picture, $100 million for one picture. During that time, when he prepared this here, color light and their combination were the base of painting Pierre-Auguste Renoir. He lived from 1841 to 19. Again and again, he painted outside in order to find the right luminosity which made his colors live. Together with his friends, he realized the first exhibition of Impressionism in 1874. The critics were shattering. The paintings have been painted carelessly. It is enough to make your hair stand on. It is only in 1881 that Renoir will be accepted. In the meantime, he had painted his most beautiful paintings. Nowadays, we are fascinated by the luminosity of his colors, the lifelines of the light, which show the unique kind of painting. So there you can see how this changed and how you can influence through a new style of painting. Here, you see. I think kids can do, let's say, nearly the same with systems in solution. I have to show you more. This is here, let's say, solids which are precipitating. This is another, let's say, you have a backbone solution. This is a mineral natural mineral, which I brought from Russia. It is fluorine containing, and the surface is completely nature, you see. And there you see this type of painting. Signs are such products of the genius that makes our living in this world the most blessed, the most entertaining, and the most content. That is what Gier was telling. So here you see that is also solid precipitation. These are the colors which were popular, let's say, in the last century. You see it made in Germany. And then, of course, this is probably Japan and China, where they used, let's say, these colors. It was very important that the emperor, let's say, used the color. So you can also, let's say, make on paper this by dropping systems. Yeah, that's this direction. I will tell you that's very easy. You have an indicator, and you are adding, let's say, to the indicator a base or an acid. So you will observe this also in nature, you see. Maybe you remember, especially the older one, when you kissed for the first time a girl. Let's say I can say this as a boy, you see. You're becoming redhead, because it was so exciting. And therefore, let's say, here, 2 drops are kissing each other, and then they turn the color. That's amazing, you see. You can compare this. You can make flowers. Here this is cut, and then here you add, let's say, here the liquids, and then they spread out through these doors here and on the paper. You can make a sunflower with different colors. To separate this, you have to first, let's say, give one color, then add a solution of sodium chloride to drive it out. And this is a painting. And this is flowers in a vase. You can, of course, this is here, this is a hole, here is a hole. So when you put here, it works through this opening and this opening and gives you this, characteristic pictures. So that is how these are colored drops. For you, the younger ones, science will be much easier than it has been for the older ones. These days, we are observing and making experiments, whereas in former times, people were relying on assumptions, opinions, even imaginations. For a long time, those new ways were not clear. So one or the other may always have taken them. That is a German. This is another red picture. Here now you can show, let's say, how to make branches. You take 2 glass plates, okay? Then you at the one end, you put in aluminum foil, which you have at home in the kitchen, I think so. And then in between, you put copper 1 chloride, and then it grows here, you see? Fractal structures growing up. This is a picture which you can very easily reproduce. You can can make single branches. You can use fluorescence. You can make a branch of crystalline products. You can make here crystals. When you take copper solutions, this are growing, let's say, oxalates of copper give such kind. And I asked, let's say, the boy who has done this, he told me it looks like a heap of ants. You hear you the ant, And then you see here the sticks, that of course is wood. But the kids, let's say, go in the forest, they see this, and then they compare their work, what they are doing, let's say in chemistry, with nature, for example. These are colored pictures. These are here crystals. These are branches, you see, which you can grow. The fractal structures. These are very thin plates of crystalline. So you see here the reflections of the light, which you can, this is of course a church, that's Feininger. Two different kinds of principle exist. The principle which shows the way to go, and the principle which warms the heart. The first principle is science, the second one art. Both depend on each other, and none is more important than the other one. Without art, science would be as useless as a pair of tweezers in the hand of a plumber. Without science, art would be a mess of folklore and emotional charlatanism. The principle of art prevents science to become inhuman. The principle of science prevents art to become ridiculous. So I can recommend for you, when you are doing science, you have to be also an artist. And with the art in your heart, science will grow. And you can communicate. You see, when you are born, you are not born as a chemist. You are not born, let's say, as a merchant. You are not born, let's say, you are becoming this. And this separation between people does not really exist. A good chemist can be a good entertainer, can be a good artist. I think that is very, very important. Then my last, choose a profession that you love. Then you have not to work any day in your life. Become a fan of chemistry and you never will lose your enthusiasm. So this message I give you to go home and inspire your neighbors. And that normally people are doing. Then they call me at home and say, Professor, when are you giving your next lecture? Really, I make this demonstration in the public. The kids of the neighbor waiting for you. And there are such emails you get, and then you feel good, and you have to do, let's say, teaching chemistry also with charm. That is, don't forget this, don't look serious. Enjoy, let's say, chemistry, and that makes you really happy. This message I want to give you, and I hope I have a little inspired you in this direction. And let the younger ones, if you are a teacher, let the younger ones do the picture. They have much more fantasy than normally, let's say, an old man like me. You see, we are going always in the old ways, you see. And they discover new way, new access to the world. So that is a very important way of doing exciting lectures to the kids and to the older students. So thank you very much for coming, and I hope I have enlightened you a little, and you follow, let's say, the enthusiasm in this way. Unfortunately, I could show you only one experiment. Normally, I show these experiments everyone in the public. So thank you.
Any comments or questions from the audience you would like to ask Professor Roesky?
I'm ready to answer you. So.
But the student will tell you that that's not how they study chemistry in the school. You ask them how they study chemistry in the school.
Yeah, how to, that is, you see this, I have school kids who are coming to me. And I tell them, let's say, how they can do it, let's say how they can, let's say, handle the solution. The experiments are done, let's say, by the children. Not these pictures which you see here. I have not done this. This have not done, let's say, my PhD students. No. He was in my group. He will agree that he never has done such a picture with me, right? And this is only, let's say, for the younger ones. The older ones have already made their decision. You see, you cannot change. An old horse, you see, you cannot make that it is going fast. Yeah? It's going this. That is nature. I hope you're going with a smile home and not so. Oh. So you must. I told you you must enjoy and do everything. Let's say in life, when you are doing chemistry. You also look, let's say, what other people are doing and combine this and see, let's say, because life is, you are born and you are influenced, let's say, doing in one direction. But if you are doing, let's say, only one way, you are not becoming really, let's say, enlightened of your life. Be interested, let's say, to the beautiful of, or the beauty of the world. That is also known. And you are living, I can say, in a paradise. Singapore is a paradise. And you have to enjoy it. And when you're a little sad or something like that, go, let's say, into your nice parks and enjoy, let's say, the nature and enjoy the trees and so on. That is the real life. Okay?
So I have one question to ask your advice. When we face the frustration or difficulty in studying chemistry, what is your advice to cheer us up?
Yeah. Well, if you decide, let's say, to become a chemist, of course, you want not to be an average chemist. You see that you are every day open, let's say, this door, and then you do the same reaction. You see, you're sitting at the computer, and then looking on the, oh, no, it's 10 after 4 o'clock. I have to go home, let's say, at 5. Then that is not good. Then he said, oh, I have time. 50 minutes. What can I do? Then you start something new. You see, if you're not finished, continue next day. Always be optimistic and discover new ways. Don't relax too much. You see, when you relax too much, your muscles are not growing. You see, you have to have your brain, very important. You have to have your body, must also do sports. You see, if you do not want to do sports, go dancing. With your friends, you see, you can dance, and then you enjoy the life. That is important.
You see, in school, when they study chemistry, it's a lot of what you call it the deductive method. Okay? Whereas when you are a researcher doing research, a lot of time you use the inductive method. So the deductive method, for example, when they want to learn thermodynamics, they want to learn all the laws first. Yeah? And then from the laws, they start to deduce or apply them to experiment.
Yeah. You see, let's say, the government is giving, let's say, something, paragraphs, 1, 2, 3, 4, 5, 6, and so on. So in the first term, you have to do this, and then you have to do this, yeah? Yeah, you have to do, let's say, also with fantasy to bring this over. You can do this, let's say, when you give, let's say, a reaction, or you say an equation or something like that. You can choose, let's say, something which is interesting. So to show them, let's say, how is the distribution, how is the Gauss distribution, for example. And you have to do it, let's say, in an interesting way. But that depends not of the lawmakers. Do not say, we have to do this. Do it your way. Do it your way, but include it. Do it your way and teach it. That is important. Your personal is so important as teacher. When you want to fascinate the young people, you have to spread this over to them. I have had a lot of young research and still have. So it's you have to be this inspiration. You have to do it. When you say, "Oh, must do," that doesn't work.
So any further comment or questions? Did the Nobel laureates read the books before they write the foreword? Or did they write the foreword?
Of course, let's say I wrote the foreword was I have written, let's say, to me came, let's say, from one is came from India, and he was fascinating. He had already his PhD. He did research, but he said, well, can I come, let's say, to the beginners? They are, you are doing, let's say, every lecture, you are doing some experiments and so on. And so I did not hear from him, but 10 years later, he wrote his first book. Then he sent me this. I corrected this, I improved it, and then I wrote a foreword for this. And then you can see printed, and then it's like I've done this with the Nobel laureates. He's using now my name. And he has already, let's say, the second book, and it's all spread over India. So I am called in India the guru.
Can I just ask you one very personal question? We are chemists and we are scientists.
Yes.
Okay. I have met many famous professors all over the world, but usually their children, their own son, don't want to be a chemist. I have met a very famous chemist in Imperial College. His son wants to be a carpenter. And I asked him why. He said he would do anything rather than chemistry because he doesn't want to be what the father is doing. My son decided to do physics. Very disappointing. Okay? I just wonder how you inspire your son to be such a good chemist.
I have two sons. Both are chemists. Both are chemists. So that you will not normally find in a family. So my wife was not a chemist. So when I came home, we talked, let's say, not about my research. We talked about different things. And also, let's say, of course, when my boys were sitting, we had supper or breakfast together. And they did not really know what I'm doing. They did not know. Then you can ask Peter, you know Peter, that's my youngest son. He's now also a professor of chemistry. And my oldest son is also a doctor of chemistry, but has let's say, has two professions. He has a PhD in chemistry, and he has a degree in law. So he's doing, let's say, half of his life he was in France working for a company. And then now he's at the European Patent Office in Munich. So he has both sides, you see, which he plays around. He earns much more money. A lawyer earns much money when you are than a chemist, you see, nearly 3 times what I ever earned. But then I asked them, well, why have you become chemist? Oh, father, they said, we want to know what you are doing to understand this. And I said, I was really proud, you see, to hear that from my son. If I would say, oh, become a chemist or so, probably would not have become chemist. You can ask Peter. He will give you the same answer when he comes here to Singapore or any other place. You meet him so I have a lot of people influenced. Also, let's say, all the neighbors, I can say. My wife had a big community, and boys and girls of them have become chemists. I did not speak to them, but the influence, you see, that is, it's like a wave, you see. A good wave brings happiness. When you're talking, let's say, and want to convince someone, I think that has not really, is very efficient.
That's why I see you bring the happiness of chemistry to me.
I don't know if you were happy. So normally I'd say also to the student, use your time. Use your time. When you have, let's say, good results, you make good papers, you get up. You are looking down is easier than looking up. You see, then you have a wish, you want to go up. But if you are up, then you are relaxed, and then you look down. So that you have to keep in mind that you down looking is much easier than up looking.
So, any comments? So, just a small conclusion. Thanks for your influence. I want to say the happiest period of my life is to study with you in Germany.
So thank you very much. Thank you for coming, and enjoy the rest of the day. Relax and be happy. I told you, let's say, this is a very important happiness in your life. Thank you for coming.